So I've had a chance to talk to a few people here. So I come from a construction products background. I joined Saint-Gobain in 2015 as a sustainability engineer, doing mostly energy audits. But then I went and I actually started working as a process manufacturing engineer in a plant in Seattle. We make drywall there, doing product development work and trials and that sort of thing, and helping to improve the sustainability of the products we make. But sustainability wasn't in my role, it wasn't my focus, and I kind of missed that from my previous role at the company. So I changed gears and joined our life sciences group, and I'll talk more about what that is. So Saint-Gobain is, if you're not familiar, is a really big company, and if you're from the construction, building, science sector, you're going to be very familiar with the products that we do make. So construction industry, like drywall, gypsum, insulation, roofing products. We do chemicals for admixtures. We do mobility, so different plastics and ceramics and composites for bearings and automotive seals. If anybody has been in a Tesla or drives a Tesla, if you look at the windshield, we manufacture all the windows and windshields in Tesla cars, and you'll see the Saint-Gobain logo there. Surface solutions, I mentioned abrasives, so we have a global footprint there as well. Ceramics with like refractories and kilns and that sort of thing, proppants and other ceramic products. But then the life sciences group is probably our smallest group. It's plastics, and that's the group I'm with, and we service bioprocessing, medical components, industrial and consumer solutions like food and beverage, and electronics like semiconductor fabrication. So life sciences is a global business. I mentioned it's on the smaller side. We have a little over 3,000 employees globally, manufacturing locations in 13 countries with this group. And some of the brand names that we have, C-Flex is very well known in the pharma space, PharmEd, Barblock, View Life, on so on and so forth. A lot of names maybe not so familiar to this group. So what kind of components do we make in the life sciences group specifically for bioprocessing? This is kind of our bread and butter. Tubing, so components that go into assemblies, connectors and clamps, filters, pumps, those sorts of things, and we compile these components into assemblies, and these are used for anything to do with bioprocessing. So if you imagine the Pfizer vaccine, we supply a lot of the components that are used in the manufacture of vaccines. Cell and gene therapy, so I know we do have somebody here from Kite Pharma Gilead, so they use these types of components in their process. So our sustainability goals, so we were an early adopter to the Science-Based Targets Initiative. We were one of the supporting members at COP21 in Paris. That's where we're located or headquartered. So we have our science-based targets. We want to be net zero carbon by 2050, like many companies in the room. But we have our stepstone goals by 2030 compared to a 2017 baseline to reduce our carbon in scopes 1 and 2 by 33%, and scope 3 by 16, reduce water withdrawal by 50, move to a more circular economy with using non-recovered production residue and less virgin material usage. And then this last point, and what I'm going to be talking about today, is LCA. So we have a goal by 2030 to cover our entire product portfolio, even outside of construction products, with LCA. So I know a lot of people in this room know what an LCA is, but for those who don't, actually I might ask if you can raise your hand. If you are familiar with LCA as a methodology, like raise your hand. Okay, so a little more than half the room. So for those that don't, I'll jump into this just quickly. So a life cycle assessment can take different scopes. So the most common scope you'll hear is cradle to grave, so looking from the raw material extraction through transportation, production, manufacturing, delivery, the use phase, and then you'll eventually have the end of life after that product has been used. So that's cradle to grave. What I'm going to be talking about today is more cradle to gate. So when you hear about an EPD that you're getting from a supplier to put into, let's say, your building LCA model, it will incorporate the cradle to gate and maybe some extra steps to describe the end of life and its use phase. But for a lot of industries, cradle to gate is kind of what's expected. And so that's been my focus with life sciences in support of our customers, is cradle to gate LCAs. And again, LCA is just a technique, it's a methodology. to understand the environmental impacts of a product or a process over its life. So I've got an example from the gypsum business, which is where I have most of my experiences from. So I'm just going to run through this diagram quickly, but you'll have the raw material extraction, the manufacturing step, the logistics network to get that product to the point of use, so installation in a building. The building will have a lifetime maybe of 20 to 30 years. At the end of life, it'll be demolished, and then you have the opportunity there to go maybe cradle to cradle, so bringing those raw materials back into the mix and reusing them instead of being a grave where you might throw those materials away. So in the LCA method, you're looking at all the inputs to a system depending on the scope that you choose, so like renewable and non-renewable resources, as well as the outputs. So emissions to air, like carbon emissions, emissions to water, emissions to soil. And from the kind of calculus that you do in making these calculations, you can understand what the footprints are. So from a footprint side, from the incoming, you can have resource depletion of fossil, minerals, and energy sources. And on the output, global warming potential, which is decarbonization, which we're talking about today, but also acidification, eutrophication, ozone depletion. There's dozens of other categories that we could talk about when we do an LCA. So I am showing the results of an internal product LCA that I completed. I've dumbed it down so I don't say what product it is, but this is an actual LCA that I completed. It's a cradle to gate scope. And what we can use LCA to do is to understand what opportunities we have for decarbonization. So going from top to bottom, the gray is the upstream transportation. It's actually a very small amount of carbon footprint for our product, at least, is coming from that upstream transport. The light orange is packaging materials, so scope 3. The dark blue is the processing, so our operational footprint. And for us, it's all scope 2, because we actually are an entirely electrified site for this product. And then the dark orange is the raw material impact. And so it might be surprising for some people in this room that raw materials have the biggest impact for this product. For a product like gypsum, it might actually be more on the processing and less on the materials in terms of impact. So going through what opportunities we can have for each of these categories. So light orange, you could reduce the packaging that you need to use, substitute packaging materials with things that are maybe more sustainable, some biosourced plastics, biosourced cardboard, obviously. In the blue for the processing, process efficiency improvement opportunities are always great. Electrifying your process, which I mentioned for this site. Investing in renewables, which I'll talk about in the next slide. And then for the materials, incorporating renewable raw materials, substituting raw materials, and reusing and recycling and reducing materials that are needed, and diverting those from waste streams. So jumping back to the renewable electricity sources, I know a lot of companies here do these kinds of projects, so virtual power purchase agreements. So we've been very aggressive with this in our North America region to decarbonize our scope 2. So we have 3 projects that we've initiated over the last few years. And this is going to allow us a 70% reduction in our scope 2 emissions across all of our North America sites, which there are over 150. So this is a really good step forward in terms of decarbonizing our products. So giving another example of the raw material piece, we could substitute some of those raw materials. How do we innovate in that way? Can we recycle waste streams and bring them back in and use them in our products? So I'm going to give another example from a different product study that I'm doing, where currently it's a fluoropolymer-based product, and fluoropolymers, outside of having those legacy impacts of being resilient in the environment and not breaking down, they also have a very high global warming potential in their manufacture. So for this product, it's PVDF in red. That we're currently using for this product. It's an injection molded plastic product. So again, the processing is very minimal, and really we're looking at the material impact. For this product specifically, the mechanical properties, using PVDF is a little bit overkill. So maybe we could consider some other materials to achieve the same performance, but not have to use something that's so impactful on the environment. So we looked at nylon, a bio-based nylon specifically, which has a much lower footprint, and this does exclude biogenic carbon. So this is only looking at the energy that's required to process that, and then the carbon we'd be avoiding from not using a petroleum base. And then also with a PBT, polybutyltylene, recycled content, so it's made from PET bottles as the feedstock. Again, looking at that from like a non-biogenic perspective, there was none to begin with, but it actually performs better than the bio-based when we exclude the biogenic for bio-based. So looking at these two, we found the performance was good for both materials, and we're able to share this with customers and say, hey, would you be interested in us trying something different? This is the carbon performance we think we could achieve. And we have been getting green lights left and right from all of our customers saying, yes, this is awesome. We would love to move to something using one of those two materials. And we're probably moving forward with the blue, this recycled content material. And it's going to have a huge reduction in the carbon footprint by at least 10 times. Again, just an example, but this is, again, the power of LCA. So all three of these numbers are coming from publications, literature data, of LCAs that have been completed for these different materials. So for that same kind of dummy product that I mentioned before, this is, instead of being a bar chart, it's a pie diagram showing the split of the footprint. And this is our kind of decarbonization strategy for this product. So again, going back to that list of opportunities that we identified, which ones can we implement today? Which ones could we implement tomorrow, and which ones can we implement later? So everything with a green dot is done today. So the first one, we did a process improvement. We made our actual processing step a little more efficient, so we're able to knock down the carbon footprint by 8%. The next is going back to that renewable energy credits from VPPA, a 20% reduction from doing that. And then for packaging, in yellow, this is something we're evaluating today. So looking at some packaging reduction opportunities, going with lighter weight packaging. And then maybe next step would be to look at bio-based plastics. And again, this is a very sensitive market to materials, and validation is a requirement for bioprocessing. So it's something we'd have to validate with a customer. So that's maybe a 1 to 2 year process. So that's in development. For dark orange here, scrap reduction in our own process would be, reducing the amount of raw materials we have to use. And then a big one that we're looking at today is, can we incorporate bio-based materials into this product specifically? And that would offer a really big reduction. So again, about 15 to 20%. And then for this last blue piece, moving forward with those VPPAs, but also looking at on-site solar and other renewable energy certificates, can we get that to 100% and how quickly? So that's something we think we can do by 2030 for the North America region. So with all of these items combined, that would be I think that's a 69% reduction in our carbon footprint, which again would be great for us and great for our bottom line in terms of carbon, but also for our customers that are expecting these types of reductions from us. And this last slide is just to give a little bit of background and context for the industry and the regulatory environment. So on the left, we have PEG. This is the Pharmaceutical Environment Group. It's made up of a group of end users, license holders, so pharma companies, and they've come together and they've announced just recently that they want to push for product-level LCAs to be completed for their products, and that's going to require lifecycle inventory from suppliers such as ourselves to allow them to make those calculations. So this is starting to push us as a supplier to this industry. On the top right, the NHS, the National Health Service of the UK, is instituting product carbon footprint requirement starting in 2028. So even though that's a few years down the line, we need to be ready for it. So we're anticipating that requirement in that market, and it's likely that'll spread to other markets such as the rest of Europe and then over to the North America region. And then from an industry perspective, Bioforum is a consortium for biopharma manufacturers and suppliers to work together to decarbonize and address other sustainability topics. And product carbon footprint came as kind of a gap for us today because it's a really complicated industry. There's a lot of interconnected supply partners with tiered supply networks. So we'd consider ourselves a tier 1 supplier, but we have in tiers ahead of us that are supplying components and materials. So how do we collect data at scale? So we're developing a framework for developing product carbon footprint, and we're basing this off of the chemical industries Together for Sustainability Product Carbon Footprint Framework. So I'm really excited to be working on this. We're getting very close to announcing this more publicly and trying to find pilots. But yeah, so that's all I've got, and I'd be really excited to talk to people at the panel discussion. Thank you.